All right, good evening, everybody, to the third week of our masterclass series on comparative cloud technologies. The wonderful Tim Jones is going to take it away in just a moment, talking largely about storage and database technology. Welcome to anybody who has not yet been in one of these webinars. You can find the previous 2 weeks class materials at learn.itmasters.edu.au. And I believe that the 2 previous webinars have been uploaded to YouTube as well. So you can find those if you've missed out. Thanks very much, everybody, for coming along. Just a reminder as well that technical questions, we really encourage, participation and, audience participation, chatting amongst yourselves. The technical questions about the course materials can be directed to the Q&A section on Zoom, and we will try and answer as many of those questions as possible. And then any other comments, questions, or particularly questions about the kind of administrative side of the course can be directed to the chat section. We've got Kit and Hannah standing by doing sort of the tech support / administration efforts for us this evening. Thank you very much, Kit and Hannah. And they will also be able to answer any questions that you have about that kind of administrative side of things in the chat section, as well as being accessible via learn.itmasters.edu.au for further questions tonight and at any other time throughout the short course. My name's Jack Stewart. I'm a course consultant with IT Masters, and I am now going to hand over to the illustrious Tim Jones, who's going to tell us a lot more about cloud technologies. Thanks very much, Tim.
Thanks very much, Jack. Welcome to week 3, everyone, of the Cloud Masterclass. So to get into it, all right, so we're on week 3 of week 4. So if anyone didn't join one of the previous classes, as Jack mentioned, they're all available up on YouTube. So you can catch up, you can do the tests, and you can get the certification still. You don't need to join these live, even if you're joining this one without having done the previous ones. This week, it's all about file storage databases. Right, so we're going into a bit of detail about these sort of technologies, and in between we're also going to have a bit of an in-depth view with Jack around what it looks like to become an IT Master student moving forwards as well. So to start with, jumping into file storage. So first of all, what it looks like from the perspective of the main cloud platforms. So as usual, looking at the main players that we see in the marketplace, AWS, Azure, GCP. Of course, there's IBM, there's Data, there's other companies as well, but these are by and large the biggest players, especially in enterprise companies. And so what we see from AWS is a technology called Elastic File Services. We see Azure file storage, and we see FileStore from GCP. And as I mentioned previously, very much all of these technologies that we talk through this entire course are synonymous, mostly between each of the different cloud service providers. There's some edge cases and some slight differences in the way that they implement these major technologies, but for the most part, you can think of them as very much the same. So first of all, what do we mean by file storage? So this is files that we access over a network share. So this could be something that you access from your home computer, accessing directly into a cloud environment, from your corporate office, from your laptop, connecting through a direct connect or a VPN connection into your cloud interface, or for application use within the cloud or outside of it. And this is very much in line with what we have in data centers as well. So this is a technology that was that's called network attached storage, or you might have heard it as NAS. And there's companies such as NetApp, which made most of their business out of selling network attached storage for enterprise class applications and the ability to share not only files, but to have basically the way that you run applications run off this shared network storage as well. In the home environment, you might have QNAS or a different device that offers the same sort of capability as well. So good for user or application use cases as mentioned, but we've got some limited capability with file stores around how we can search them. It's a hierarchical structure, as you can see from the diagram on the right-hand side. If we want to search for an individual file, we need to search directory by directory. Right? So we don't have a global view of all the files, and it takes some time to go through and find it, especially when we start to get up to very large numbers of files. So say, for example, especially as we move into the world of automated systems, IoT, etc., when you have a large number of images or video or other things that need to be searched through, when there's thousands or millions of events per day, you need specialized technology sitting on top of it to go through. The file system itself doesn't scale to that many objects itself. But from a cloud perspective, the files that we have within the environment are quite durable. The standard sort of SLA we have across the 3 platforms we're talking about is a 99.99% SLA of uptime availability that you'll be able to utilize the environment. So we're only talking about a small amount of time per year that you would expect not to be able to access your files. So it's a good technology. But then we come across to block storage. So with block storage, again, across the main 3 platforms, we've got EBS, which is the main Amazon platform for block storage, Azure page blobs or premium storage, managed disks, or persistent disk with GCP. Now, what we're talking about with this is synonymous with the idea of your hard disk in your laptop, whether it's an actual spinning disk or an SSD, whatever the case may be. It's some storage that you can directly access and utilize, and is something that you can run an actual operating system on. So if you have a file store, for example, that we talked about before, you can't boot an operating system off that specific file store in the cloud environment, simply because you need to have an operating system before you can actually access a network file system. So the way that we talked about the OSI model and the way that different capabilities come into play over time, the running an operating system requires a certain amount of capability to start with. In office situations, you can do things like Pixie boots for your own NAS environments, but that's not the way things work in a cloud environment. So within cloud, to boot, we need a block-based system to boot off. All right? And within that, we write anywhere on the disk. So it takes care of where it's writing to, and the writes are done in certain block sizes. So whenever we do an update to a disk, the update is done so we rewrite the entirety of the particular block size that we're looking at. So that might be 8K, it might be 64, it might be 256K. And the difference in block size means that if we're making a very small change, like just a couple of bytes, to something that has a 256 kilobyte block size, we need to rewrite the entire block back to disk again, or back to SSD. All right, so it can slow things down. But if we have a very small block size, it can impact read time, because we need to request a block, request a block, request a block. All right, so we end up with latency or lag issues. So this is around technically what we're doing with delivering performance and capability from a disk perspective. So the real advantage of it, though, is that, again, we can write anywhere, allows us to have an operating system sitting on there, and can be very fast for reads and writes, because we can just keep on writing strings of data to disk, basically in a sequential row along a track within the environment, which means that we don't need to, if we're using physical disks, we don't need to move the head of the disk that much. If we're using SSDs, it can just basically take the information and chuck it in there straight away. So same with reads. If we have sequential writes, we can have sequential reads, which can be very fast as well. So we have very little capability with this, though, for being able to do search. We don't have any metadata that's associated, and we don't have any built-in recoverability to a standard disk. So if we have a disk failure, we have an outage, right, for that particular environment. So any capability for search, metadata, or recoverability needs to be built into a higher level of abstraction for what we're doing on a layer above what we're doing with the actual hard disk system itself. One of the other things that we have within the cloud environment is what's termed as ephemeral disks, disks that aren't designed to stay around after we have a system shutdown, for example, or if we have an outage. So these have the advantage that the block storage that we were talking about before is accessed from across the network. So there's central storage within the cloud arena that we have all of the storage actually sitting on, and it comes to the compute nodes for them to be able to access it. So it means that any read or write needs to traverse the network, which means that there's a bit of latency, a bit of time for it to go across the network, and a bit of additional slowness of all of that waiting, especially if you've got a very chatty application that keeps writing and reading all the time. If we have ephemeral disks, though, these are disks that are built into the actual chassis or racks that we have within the cloud center, data center itself. So part of the system deployment model, and we have fast SSD disks that are available locally. Now, because they're local to a particular rack, they can't be guaranteed that they're going to survive any major outage, which is why we've got central storage elsewhere. And the way that they architect these systems is that you don't get your data back. So they're very useful for when we've got elastic application architectures where we don't expect to see any long-term storage, and we've got something else in place to manage long-term storage capability. And we also have very low latency and high throughput from this. So great performance out of it, very low latency, but we don't have any durability expectations for what we see. Just a question before I move on to the next section, just a question from Rex. Should all files stored in cloud be encrypted just for the known person to access? Is there other ways to protect and secure the files? So by default, all of these technologies have a layer of encryption within all of the cloud arenas. So any data at rest, so when we're talking about data at rest, it's when we actually write something to disk, or in the old days, you'd write it to tape or something else. All of that within the cloud arena is encrypted. All right? So by default, we're utilizing the AWS keys and the encryption capability from AWS or from Azure or from GCP to deliver that capability. So if someone within AWS or Azure or GCP that had enough admin rights, they could potentially read the information because they may have access to the keys in some other way. If we wanted higher level of security, we can use our own keys or an HSM, a hardware security module that's available from the cloud service providers, or we can provide our own keys. So there's different layers of security that we can provide, and that security can be applied at encryption for data at rest as well. All right, now we move on to object storage. So similar format here, we've got Amazon's S3, simple storage service. We've got Azure Blob storage, or we've got cloud storage available from GCP. And here it's a flat storage model. So all of the files, if you think of it in terms of a file system, our regular old file system, the objects are all stored in the root directory essentially. So they're all at the same hierarchical level as each other from an object perspective. The way that we deal with things slightly different here is that we have the systems available for us to have a great deal of metadata associated with each of the objects. And part of that metadata is pretending that the objects are actually within a hierarchy. So we have a folder structure or a quasi-folder structure that we tie to the object, and that metadata is basically just information to show where it is and to allow us to browse information or keep it slightly separate. Now, because we have metadata, all of the information about time and other information that was stored at the time that the object came about, it becomes much more readily searchable. Right? So it works really well with applications that might be time-based. So we want to pull back certain objects from a particular period of time. In a file system, if we had a file environment that was across many, many folders because we had millions of images being saved to disk all the time, it could take a very long time to search through that type of environment. In this type of system, we can do a search of the metadata and we can get information back really quickly. And this is really designed for how we utilize non-structured data. Right? So we can have some component of structured data in here as well. So we can have some components like CSV files or other dumps of file objects that come into here. And this is where we start to look at things like data science and the capability to do data mining through object-based stores where we can correlate information across multiple areas. So for example, being able to correlate information from security events to weather information, to time of day, to when particular staff were in the office by pulling together multiple different streams of information and stitching them together through data science and data analysis. So if we go through, one of the things which is pretty cool is the Flaws website. So this is something that I suggest everyone has a look at because it not only goes into a fair bit of detail on the AWS side of how you access the file storage, but it also gives you a great idea of all of the different ways that people can hack into a file store that's web accessible. So it's a great site, really well put together, so recommended. So have a look at that after the course. All right, now to just have a quick look at a demo. So this is just a fresh instance that I've loaded up from the course that everyone's got access to. And from within here, we can go into S3 and have a look at what that looks like. Now, if we want to go through and create a storage area within the Amazon environment, that's called creating a bucket. So if we go in, create a bucket, and if we go through and just call it my bucket, one of the things that it comes back with is bucket with the same name already exists. Now, what this means is the bucket names within AWS need to be globally unique. We can't have a bucket name that anyone has used at any time before. So,
Tim, just really quickly, are you able to zoom in once again? So, yeah, perfect. Thanks so much.
Cheers. No one else has before. So if I go IT Masters, Tim Jones, there shouldn't be anything that's been created like that before. And I'm going to create bucket. We've now got a bucket available for us. So this means that we've got a very simple information available that we can go and put data into. So if I go and pick this up, we can drag and drop a couple of files over here. Maybe if it's going to let me. There we go. So here, saying that we're uploading a couple of files, pretty small. Now that we've got them in place, you can see that they've both successfully come up. Within here, one of the things that we can do with any of these is we can make them web accessible as well. So we can essentially make a very simple website super quick. So we can enable static hosting and give the names that we've already created within here. And save that off. So now we have these websites available. We've got objects that we can see. If we select it, we can go through and say open, and that'll go through and open completely fine. Now, what I'm doing here is I'm not accessing directly through the internet. This isn't the internet accessible view of the file. This is an internal view of what the file looks like. If I go through and go to the website, so anyone else can access this as well. If you, so itmasters-timjones-.s3-website-us, etc. You can hit the same website and you'll see I'll run into a problem, forbidden. Right, so by default, one of the things that I mentioned in the security section is by default, AWS, Azure, GCP, they build their systems to be as secure as they can to stop people from running into problems. So we can come through and change the bucket settings so that we're saving to allow public access. And we can also go through and create what's called a bucket policy. And I can copy and paste one that I created earlier. And from here, this allows us to save it off, close, and we've now got the bucket policy in place. If we come back over here, this should allow us to go through and access it. If we go through and put in something that doesn't exist, we should end up with an error message. Right, so this is our error message that was part of the file. So this is all easily accessible. You can see you've got a website up and running, super fast, but it's easy to do. I've used it myself. It works in with the DNS that's available and things like that as well. All right, so now that I've gone through that, before we launch into any questions around the file area, I've got a few words from, I'll just stop sharing. Jack is going to come on board with a bit to talk about the IT Masters offerings. So are you all good, Jack?
I am. One moment. Allow me to share my screen. All right, so thank you, everybody. I'm going to just talk really briefly about some of the opportunities that IT Masters and CSU can provide to study full-length postgrad IT courses with us. So as I mentioned in the first week's webinar, one of the reasons that we present these short courses is because we believe that the content that we provide really speaks for itself. So it's a really good opportunity to show anyone who's interested in pursuing higher education in the field to kind of get a bit of a taste of what our courses are like and what they can expect from our subjects. So the short courses that we present The content is taken quite directly from subjects that we offer. So for example, Tim has taken a lot of the content in this short course. Is this? Yeah. From the subject that he teaches, Architecting Cloud Solutions, which is available in several of our courses, which are Cloud Computing and Virtualization, Cybersecurity, and Networking and Systems Administration. So there are obviously many people who are taking this short course today purely out of interest or for enrichment, just to deepen their own kind of professional or, interest-based knowledge. Some people might be looking for further sort of study opportunities. There are some people for whom the kind of industry certification pathway in the industry, I'm going to say the word industry too many times, I apologize, is a little bit more appropriate. Some people who are looking for more of a traditional kind of university style formal educational opportunity, and some people in the middle, so who might want to kind of combine those approaches and things like that to increasing their kind of level of qualifications in the IT field. So, for example, one of the reasons that IT Masters essentially was founded is to kind of bridge the gap between the industry and the academic spaces when we're talking about IT education. So, as I'm sure people would be aware, there are there have been a lot of developments. It's an extremely fast-moving field. Sometimes the traditional university system has not always kept pace with developments in the industry, and there are a huge number of vendor certificates and other kinds of qualifications that are available to people within this industry, which can teach you just as much as if not sometimes more than university-based qualifications. And there's a lot of on-the-job learning that a lot of people do as well, which is incredibly valuable and provides, a lot of experience that can't necessarily be quantified in a traditional kind of educational model. We speak to people who are going for jobs, highly technical roles perhaps in non-IT focused organizations, and they're struggling to get a foot in the door because HR type professionals don't really know what a CCNA, CCSP, CISSP or AWS certification actually entails and the level of expertise that requires, but they do know what a graduate certificate or a master's degree means. And so that can sometimes be a little bit of a stepping stone for people into the industry kind of positions that they're looking to get to. So why study with ITM and CSU? I'm glad you asked. So the full length courses that we offer graduate certificates and master's degrees. And I think one of the biggest benefits for IT Masters being involved is that we can take our understanding of the course and the industry, as well as your goals and objectives, and tailor a really sustainable and suitable study plan for you. So we really prioritize offering students flexibility and a broad range of options across our courses in terms of the subjects available to study, the courses that are available, and then also trying to find the best option for each student within the course that they choose. So we really want to make sure that each student has the opportunity to capitalize on their strengths and enhance the skills that they're looking to enhance, learn the material that they don't already know, and avoid making people kind of sit through courses where they already know the material, possibly, well enough to even teach it just for the sake of kind of ticking a box. So we'll talk a little bit more about eligibility in a second, but this approach has made us market leaders in IT, and we're really proud of the way we've been able to kind of achieve this for a really broad range of people. So some of the major benefits are the different pathways to entry. So we allow entry without a degree into a postgraduate level course if you've got sufficient industry experience or industry certifications. And then you can continue into a master's even without a bachelor degree to start with. If you have any bachelor degree, you can start in a master's. And then people who don't even have a tech background, it's not necessarily a handicap. We start people without a tech background with these short courses to build up the basics. We want to try and set people up for success. And we, have flexible options. You can study between 1 and 4 subjects at a time, depending on what works for you. The subject structure and things like that. It's all really thought out to be as flexible and as accessible as possible for as many people as it can be. And we have a variety of courses, including one that's actually specifically tailored It's called the Graduate Certificate in Computing Career Transition, specifically tailored for people without that specific IT or tech background to transition into this kind of career. There's also the opportunity, if you are an Australian citizen or permanent resident, all of our courses are available on Fee Help. So that's a huge benefit to people rather than needing to kind of pay up front. And also if you're a citizen or permanent resident at the moment for 2022, there is a Commonwealth supported place scheme available for our graduate certificates in cybersecurity, cloud computing and virtualization, networking and systems administration, and the graduate certificate in computing career transition subjects. So there's a lot of those pathways. As you can see on screen, we offer 6 different intakes per year as well. Again, part of that kind of flexibility and accessibility that we really strive to provide for all of our students. So there are a variety of options. The pathways are pretty endless, and I'm very happy to speak with people about the kind of pathways that they're looking for, whether that is, studying now and then kind of applying for jobs, or kind of applying for jobs and then learning on the go. It's very desirable for a lot of people, particularly those with existing kind of tech experience. There is a huge demand at the moment, so particularly relevant to this short course, huge demand for people with experience, skills, expertise, and qualifications in fields like cloud computing and cybersecurity in particular. And employers are sometimes willing to subsidize study that's relevant to the job, as well as that demand right now being really, really high to the point where people are being hired while still studying the course, purely because the employer knows that they will have that qualification very soon. So as I mentioned earlier with eligibility, we really like to recognize the effort that students have already made. So whether that's vendor certification, work experience, if you're certified by the Australian Computing Society, which you can find out more about just on the ACS website, you can get some course credits as well. So that's being credited for a subject. So you can lessen the number of subjects that you need to complete in order to achieve a graduate certificate or a master's by up to 50%. If you've got the right vendor certifications in the past, if you can demonstrate your experience to the ACS or your work experience, we're able to kind of assess that as well. The short courses, so these short courses such as this one, if you complete and pass 3 of those, we will award you 1 subject credit towards any of our postgrad level courses as well. So that's up to 25% of a graduate certificate just because of completing 3 short courses, which is always a nice little kind of sweetener, makes it a little bit more appealing as well to kind of be able to try it out, decide that you would like to study, and then you're already 1/4 of the way there. And if you've got previous postgraduate level education, we'll also assess that for relevance and can potentially award you recognition of prior learning for that as well. So what now? Feel free to put any questions about eligibility or course pathways in the Q&A section, and I can answer them at the end of the webinar. A large part of my role at IT Masters is assessing the eligibility for study and for recognition of prior learning. So my email address is there, and I will put it in the chat of the Zoom once we finish presenting this, as well as the address for the eligibility assessment. And very, very happy to discuss with any of you potential course pathways for any of the courses that you might be interested in. And check out our website, other short courses, and have a bit of a reflection on which pathway might suit you best if this is something that would interest you in the future. So thanks very much for having a little bit of a listen about the potential postgrad study options for you. And I'll hand you back over to Tim now. Thanks.
Yeah, thanks, Jack. So just before we get into the questions, just off the back of what Jack was saying, to give you my experience, I did not manage to, for a number of various reasons, didn't manage to complete an undergraduate degree, but in 2007, I managed to get 50% credit for the entire master's course and did a speed run through my master's in 1 year. So it's a hairy time to head through and get through all of that, but it gave me a well-regarded tertiary qualification in quite a quick time, and has been quite valuable to my career since. So yeah, I recommend it. Okay, so just before we get into databases, there was just a few questions that came through about files that I've marked here. So first of all, what is the difference between file storage and block storage? So when we talk about file storage, it's around the technology that we're using to access the objects themselves. So we're using a technology like CIFS for accessing Microsoft-based type sharing, Samba, or NT-based file sharing is through a CIFS protocol, or we might be through an NFS protocol. So what we're doing is it's protocol-based, it's requesting data based upon an actual file itself, or looking up file information from a system. So protocol, a higher level order that we're accessing information by. When we're doing block storage, we're requesting specific blocks. We're saying we want, if we're looking at an old hard disk, we're saying we want sector 5, track 126 on platter 3, right? So, and we want to pull that information off there. So it's a very different way of accessing information, but and using different technologies to do so. The question from Leo: would accessing the storage from microservices behave in a similar way as would a VM to the cloud storage? So it's certainly possible. When we're talking about microservices, most often we're talking about accessing through containers, Kubernetes, or through function as a service or serverless technology. So we can grant, all of the cloud service providers have really robust identity and access management systems that allows us to not only give rights to individual users, but to give roles and access to applications and other services that we run within the environment. So we can create, for example, a file share and give rights to that file share to a particular container or to a function or something else. So we can absolutely use these within microservices, but it requires just a bit more planning than what you might have in a virtual machine environment, where you can connect up and test things from a command line. So the short answer is yes, but you just need to have a bit of thought about it. Another question from Leo is, where is block storage used mainly? All right, so it's absolutely always used as our in the cloud environment for our boot system, our operating system that we have on our environment. So it's whether it's an ephemeral disk or whether it's a different type of block storage. The other space is it's often used for when we need to have high-speed access to data. Right? So if we're running a database, for example, we're running our own particular type of database, the speed with which we can make updates and the access that we have to make sure we don't run into problems like file locks that we might have in a file system means that running a database, we would need to run it with a block type disk rather than a file system. An object store, we're pulling down the entire object every time we want to read it, and we're writing back the entire object each time. So an object store isn't appropriate for something like a database unless we structure it completely differently so that each element is an individual object, but then that's very different in itself. Question from Derek: are the block sizes dynamic or predetermined during initialization? So this is set when we create the disk. Right, so when we basically do a format command or something like that, it predefines how that disk segment or that disk partition is actually accessed. From Grant Stevens: Tim, do the major CSPs offer similar functionality to SAN technologies? That is network file copy, that is file transfer, which doesn't involve processing resources from a server. So there's some capability for this. There's the built-in capability into database systems to provide it. We can have distributed systems, especially for file systems that allow us to have something like a distributed file system that you might have from the Microsoft world. If we want to do it with block level resources for virtual machines that we have in the cloud, we can go through and have some copies of that. We can have some backup information as well, but it starts to get a little bit more complex than what we might have in the general enterprise environment. So certainly the technology is all there. You can do all of the things that you could do in an enterprise data center, but often there are better cloud-based technologies than the old ways that we would do things across a prod and DR site. So looking at things through a different lens from the way that the cloud technology offers to do things can give you a better outcome. Can the operating system be run from an ephemeral disk? Yes, yeah. So that's a very common way that we run things, because when we start up a virtual machine in the cloud environment, we can give it startup information. So it can go and download all of the programs that it needs to run from a central store or something like that, and it can be up and running. All right, so this is especially useful when we want to have a scalable environment. We don't want to pull all of that information and manually install applications. We want to have them install automatically, or we can run a system from basically a cloned environment. We can create a template of one of our virtual machines and have that brought up on an ephemeral disk as well. So the only thing that we're missing out on in that situation is, again, if we turn it off or it shuts down unexpectedly, we lose the data. So the whole thing is we don't store any important data on the local disk. From Anonymous, we have, so having metadata available to an environment, this would affect speed in retrieving the data. So not the speed of retrieving the data itself. This is the speed in which we can search for the data that we're after. So once we know the object or file or anything like that that we're looking for, getting it for an object store or a file store isn't going to make too much difference. The metadata provides us the capability to find the information we're looking for rather than retrieve it. And last one I'll do before heading into the next section is from Priya. How about backup method for all cloud storage, ephemeral block object storage? Maybe we can back it up offline or online, or maybe something, some type of storage in cloud. All right, so absolutely. So this is something which is very common that we have in the cloud environment. So yes, we can create snapshots of any of our disks that we have if we're using EBS volumes. So I don't think you can do it for the ephemeral volumes, but you can for the EBS volumes or file or objects. And the storage location that all of that goes back to is the object store. So in the AWS world, that's talking about Amazon's S3 platform is the backup space that we put all of these things to. Now, one of the things which a lot of companies doing are migrating to the cloud, and the migration to the cloud is basically taking their infrastructure as is, their virtual machines, and moving it from their data center to the cloud space. And so they're not taking advantage of a lot of cloud capabilities. And as such, they don't work in so well with the backup or other capabilities. And they may also have existing data centers that they're continuing to back up as well. So that's where, like the company that I work in my day job, they've got a tool called Data Domain as an example. And there's plenty of others from other companies where all of those companies have integration with cloud capabilities now as well, so that you can have all of your backups from your data centers getting backed up to cloud providers. We can back up our virtual machines in the cloud to the same space, and we can have a central console for how we manage the backup and recovery, and being able to, for example, restore our systems from backup directly into the cloud, into our data center, or anywhere using smarter tools. So there's quite a big market now for third-party tools that can provide a much more end-to-end view of data security and management, especially when you're looking at multiple data centers and multiple cloud providers. Okay, so we'll go and launch into databases now. All right, so just to start with, what are we thinking about when we're looking at databases? So the first one is the scalability of the database. Right? So will the solution be able to scale up? Then we're looking at the storage requirements. How much stuff are we chucking into the database? The object size and type. So what sort of information? Is it just some text? Is it some numbers? Is it a whole bunch of files, or what we called blobs, which is an acronym for binary large objects. So if you see blobs anywhere, it's just basically talking about files that you would store somewhere. Well, finally, we talk about as well durability. So do we need to make sure that all of the data is available all the time? How do we deal with recoverability? Do we need to deal with things like consistency? So if we're having reads from two different clients, do they have to have exactly the same information? All right, so and when we're talking about database, for anyone that's not familiar with it, what we're talking about is essentially a store of data in a somewhat organized way. So if you think of an Excel spreadsheet and the columns that you have on there, that can be thought of as a type of database of where we can have columns and rows of data that has a whole bunch of information in there. So we have two separate key types of database across the board. So the first one is relational databases. These are now what we would term as the traditional database types. All right, so Microsoft SQL Server, Oracle, MySQL, DB2, PostgreSQL, MariaDB, a whole bunch of other database technologies that are based upon the idea of having multiple tables and having what's termed as relations that work between them. So you might have a client number and the client information in one table, and you might have order information in another, where you have product numbers tied to customer number or something like that. And you build applications and information and capability through these relationships, and it ties very closely with business needs and how the business actually operates and processes data and information. Now, non-relational is something that's come about much more recently. Right? So the non-relational databases are what we would call primary key databases. Right? And what they provide is the ability to scale absolutely massively. So when we have relational databases, they can really conk out with their capability to keep up with the number of users or the amount of information in the database when you get above a certain level. Non-relational databases are made specifically for millions or billions of objects to be within the database and to very rapidly be able to find the key information that you're looking for. So examples of this are MongoDB, Cassandra, or Redis. Right? And so the main databases that we're looking at today from a non-SQL or NoSQL side are based off a Cassandra sort of backbone, but that's not truly important. So one of the other things to think about with the database technology and the requirements that we have, now we have ACID versus base. Now what we talk about when we talk about ACID, we're saying that it's atomic. We're looking at individual components or individual cells within the database itself. It's consistent. We expect every time we read from any client, we're going to get the same information back. It's isolated. It doesn't have any requirements on other systems to give the data, and it's durable. We expect that the data is going to be there when we want it. So this is what was really tied closely to relational databases going back some time. So if you think about something like an ATM transaction. If you write information that someone's withdrawn $20 from an ATM, a cash machine, to a database, you want to make sure that every other cash machine has that same information available immediately. You don't want to have something that's eventually consistent, or that the information might just disappear, or that it might be hard to look up, or something else. All right, so we expect that type of transaction to be an ACID transaction. The other type is base. So something that's basically available, we're pretty sure it's going to be available for us. It's eventually consistent. So we'll, when a client asks for whether that client's got $20 in their account, then eventually they'll get the right information back. And it's a soft state, so that we don't have a truly crystallized version of the database at any time, because we might have multiple nodes and lots of people accessing it at the same time. So what all of this means is that NoSQL sort of generally ties towards the base side of the spectrum of having something which is a little bit less rigid in the way that you can access the information, and that the data is controlled. But in the case of NoSQL, it's incredibly scalable. On the ACID side, this is more towards the relational database side. Now, this isn't to say that you can't have NoSQL where we're deploying something which meets the ACID requirements, or vice versa. So this is just some terms that you'll find coming across working with databases, but they help really line up some of the things that you look at from the architecture of how you deploy applications and the expectations of the business. All right, so just want to check, was there any questions that came up, Jack, off the back of just the introduction to databases?
No. I think you've actually gotten on top of them all. That is extremely efficient. / people have not been answering asking new questions about these. So I'm going to go ahead and assume that that means that you've been extremely comprehensive.
Cool. Actually, I've just seen there's one here that I'll answer. So just there's a question here. Does AWS support Sybase? And do we have a choice to select DB version on AWS for compatibility or portability purposes? All right, so no, there's no support for Sybase directly. So we'll go into this in a second for the relational databases, but you can deploy an application in a managed environment, which is what we'll be talking about mainly, or you can deploy a database onto a virtual machine. So if you have a Sybase requirement, then you can just put it onto an EC2 instance or another compute node within AWS, and but you can't run it as a managed environment as such. And the second part, do we have a choice to select the DB version? Yes, to a degree. So you can't go back way in time to versions that have been superseded, but they support multiple versions. All right, so launching into relational databases. So here we have support for across Azure and AWS of pretty much all of the major database types. So we can create any sort of application, and what we're looking at here is essentially as a platform as a service. Right? So what that means is that the cloud service provider looks after all of the software and the management of the instance for us, makes sure that the software is working, and we need to manage much less than we would in the traditional world. So you still need to have some database administration, you need to have the application integration and things like that, but you don't need to do the database infrastructure management. So the benefits we have out of relational databases, so they're easy to use and they're quite understandable. Again, as I was talking about earlier, if you think of a table within an Excel spreadsheet, that can be thought of as a table within a relational database. We've got fixed rows and columns of information, and all of that is set to a specific schema, so that whenever we're writing and reading information from the database, we know exactly what type of information that we expect. Every time we make an order, we need to provide customer number, we need to provide order number, we need to provide part numbers, and the number of individual components that we're ordering, as an example of how we make an order. And if we don't have all of that information, the application won't work. We've got a common language that's used, some sort of structured query language across all of the major systems. There's different ways of reading and writing it slightly between the different things, but mostly the way that you access databases is similar. And as I was mentioning before, the relational database is ideal if we've got a need for ACID compliance, if we've got strict schema rules, as I was mentioning around that ordering-based system, or we need to make sure that we've got our data quality up to snuff, that we want to make sure that all of the data coming in meets some rigid criteria. So we don't have the capability to scale, again, to massive web scale applications. So when you're looking at a system like Instagram, then that style of application where you've got hundreds of millions of active users right now, the front end for finding user data would be using a NoSQL database and not a relational database. So if we let the cloud service provider manage our environment, so it's a bit different to what we would have in the past. So first of all, we have the host databases on premise. This is where you manage everything. So you've got people looking after the racking and stacking of your servers, your server maintenance, your OS installation, looking after your patching, your database, database management, backups, etc. If we've got it loaded, when we were talking before about having Sybase, if we wanted to load Sybase into the environment, then we need to deal with just everything above the operating system. So we still need to deal with patching our operating system, but we need to install the software itself and manage all of that. But we can make it a bit easier by migrating our Sybase environment to the cloud rather than having it in our own data center. Finally, if we have an application where the version number that we want to run is supported by the cloud environment, we can go through and use an RDS version for the AWS side. And all we need to worry about is the application level and indexes and data management within the environment. So a fair bit simpler to deploy, manage, and control than putting everything else into play. All right, so just looking at the questions off the back of relational databases. So just a question from Stephen. Description of database like Excel spreadsheet with columns and rows seems like structured data. Databases used for unstructured data. So the relational databases are all structured data. So we have to have, for relational databases, we have a schema that tells you what all of the column names are essentially that you would have in Excel spreadsheet. So if you, again, had customer information, you might have their address, their phone number, the name of the contact, and some other information that might be in there. If you need to go and add additional information, so for example, it's you need to add someone's Instagram handle from the company because that's a new important piece of information that you require for the way your business runs, and you need to have that as part of the database. Changing the schema in a relational database is often a massive piece of work. Because it can change the way that the databases work, and it can change the way that the applications interact with the system as well. Because again, when we're writing information to the database, every time we're writing, we're expecting to give all of the information to fill out all of the columns as part of a row. So if we're creating a user and we have an update command from an old system that doesn't include that Instagram piece, we might have an error in our application and the whole thing might die. So it can take a fair bit of work to just add that type of information. Now, when we go to NoSQL databases, we have a very different view of what we can do with that type of environment. So I've heard, so from Michelle Bedson, I've heard of structured and unstructured DB. How does this relate? So structured is what we're talking about with relational databases, and unstructured databases are what we're talking about with NoSQL. Right? So, and so you'll get a bit more of an idea about that, what that means in a second. All right. Would there be any advantage to dual wielding relational and non-relational databases? Absolutely. So there's always great reasons to have particular types of databases. So as I mentioned, Instagram probably wouldn't have a relational database for the way that they access their user information and looking up key information for the way users access the application itself for the front door. Right? So there'd be some sort of database, but more likely a NoSQL database. However, within the organization, they would have things like financial records, payroll, HR, and other systems that very heavily rely upon structured data that we expect to see in our normal world of how we deal with systems where we're dealing with scale of thousands rather than millions or tens or hundreds of millions. Right? So those types of systems are perfectly suited for that type of thing. And so it's very much horses for courses. And with any enterprise, you'll see just about every flavor of different database. So whenever someone is deploying a new application or you're bringing some application in from an external vendor, there'll be a requirement for a particular type of database or a particular version. And so you'll end up with Microsoft SQL, you'll end up with 5 versions of that, 6 versions of Oracle, you'll probably have some DB2 in the back end. New application writers will be doing things in MariaDB or MySQL, and then you'll have the avant-garde new developers going through and doing a whole bunch of stuff on Cassandra or DynamoDB or CosmoDB. Right. And do we still need to keep backup database in our own data center after the DB moves to the cloud? All right, so this is all around your risk appetite. Right, so the expectation is that you can back up your database to the cloud environment, and the expectation from saving an object, which would be a database backup to the S3 environment, so the object store, the durability of that is 11.9. So the expectation is that your data is still going to be there in like about 10 million years or something like that. That you're not expected to lose any bits from your database backup. So it's incredibly durable. Now, one of the biggest risks for anyone, though, within any organization is someone doing something wrong from within the organization itself, whether it's an administrator accidentally deleting things that they shouldn't do or someone doing malicious damage. A lot of this can be controlled through identity and access management again, but there's always risks of that. And some companies like to make sure that they've got ongoing offsite, cold site type access to their storage. But you can do a lot of those sort of capabilities and things through correctly managing and implementing your cloud service capability. Okay, so we'll launch now into NoSQL. All right, so here we have, again, DynamoDB or Amazon Neptune from AWS. We've got Cosmos DB, Azure Table Storage, and Azure Time Series Insights from Azure, and GCP has Cloud Data Store and Cloud Bigtable. Now, the main area that I'm going to look at is the unstructured side of databases. So this is using the standard NoSQL that's based off Cassandra type technology for how you deploy a NoSQL database. Right? There are other types of unstructured or NoSQL databases, such as graph databases, time databases, etc. Right? So this allows us to have information on physical locations or on time-based data that might come from security systems or anything else. All right, so there's some specialized use cases where you utilize a specific type of NoSQL or unstructured or non-relational database to take that on. And that's where we have something like Amazon Neptune or the Azure Time Series Insights as specific types of NoSQL database. Right, so just a quick one. There's just a question of where did the NoSQL name come from? So basically that it's not your standard SQL. Right? So it's just something different to standard SQL. So all of these NoSQL type systems are fully managed, non-relational, and they're key value database services. All right, so what we mean by key value is that we, within standard relational databases, you might have heard the term of primary key. Right? And this essentially is the sort order of the database when we're talking about relational databases. When we're looking at a key value database, what we're saying is that in a similar way, it's like a primary key, but it's also the only thing that we need to know about a user that absolutely needs to be there. And because we're able to look up just this information, we can find them super quick. Right? So just bear with me. I'll while this is going, I will come across here to show you what it looks like within DynamoDB. And it just takes a bit of time to create a table. So I'll just create my table. So this isn't one that, oops. So this will go away and create a new DynamoDB table for me. So it'll run and start creating things. So what we have with this is the ability to really scale in a huge way. All right, so because we're keeping information just about our primary key, all right, so our key value, it's a key value database. When we're doing searching, we're doing it just on that individual user. So if you imagine that you're playing Call of Duty as an example, you log into the game and you want the game to find your information and your friend list and your kill to death ratio super quickly. All right. So if there's 300 million people in the game at the same time, if you're using a relational database with that many users on board, it would need to first of all find your user and then do a join to find all of your friends, look up your friends within the same table, and then go through and look at the kill to death ratio table at the same time and probably do the same thing for all of your friends. All right. So as you can imagine, there's a lot of recursion that happens through that of looking up tables, making connections, looking up other tables, etc. So if we had a massive amount of people online at the same time, that's a huge amount of searching, a lot of transactions. All right. So if we have a NoSQL database, we look up just our username, and there's no limitation to what we can put in any of the columns. We can have columns that are shared, right? So we can have the number of kills that we might have had, the amount of time that we spent in the game, the number of achievements that we've got that might be common to all of the users across the board. But we can just continue to add information. We can add columns with any new column name that we want to, and pull that information back whenever we want. So the columns that we have might be other users' names within there that we have in our friends list. And we can immediately pull them up, very rapidly find them in the NoSQL database and pull their information back that gives us the KDR information or other stats really rapidly. So the architecture of the way the application works with NoSQL and the back end of the NoSQL system, DynamoDB, Cosmos DB, or Bigtable, they all run incredibly fast for this type of application. And it requires the application to be specifically written to work with this type of database technology. All of these are serverless technologies as well. So you don't deploy a server type. You don't have a virtual machine or anything like that that operates. When you run an RDS instance, you essentially have a virtual machine that gets managed for you, but you still need to pay for all of the runtime for that actual virtual machine for running RDS. For this, you're charged based upon the number of transactions and the amount of data that you have stored within the environment, and a couple of other metrics. But for the most part, if you're using it for a very small space, then it's not going to cost you a lot of money, but you can scale it to as many objects as you require. And it's also important to note that it's enterprise ready. So although the table that I just created took 15 seconds to create, I could create applications that were incredibly robust based off exactly this same technology. I don't need to use a different version. I don't need to do anything else. I can create something in a development environment and rapidly deploy it into production and have it scale to millions of users immediately. So what do we use this for? So again, if we've got a heap of data, so if we've got a lot of data coming in, relational databases don't work particularly well with this. So there are some always use cases where it might be appropriate, or you might want to do it that way, or it might make sense. But generally speaking, if you've got masses of data, and especially if you're creating a brand new application, NoSQL is great for that. If we want to potentially scale quickly, and so we continue to add a whole heap of users or something else, if we're creating all of these users and connections in a relational database, you can imagine there's not only the individual row of data that gets created for an individual user, but all of the relations with everything else within the system as well. So this way of scaling the application is super quick. We don't need to have any complex joins. So we're not expecting to be able to have a join to a join to a join to a join. In the example that I had before of the customer information joined to the order information, joined to the stock information and the delivery docket or something like that. Right? So complex business-focused joins and information can be troublesome and also harder to enforce in a NoSQL environment than they are in a relational environment, right? Because relational databases are made to support specifically those relational connections between the tables. So the key features we have here, again, we have the NoSQL tables. Items can have differing attributes, so we don't need users to have the same information or the same column information when we pull our information back. So if we start to decide in the example that I gave before that we want to have users have an Instagram handle in their account, I can just add it to the users that I know. And the expectation is the application will look to see whether there is that field available. And if it's available, it'll use it. If it's not there, it won't. So again, it comes to how you architect the application as much as the capability of the database itself. We also have in-memory caching, which is part of why it can operate so quickly. So we don't have the full database in memory. So as one type of database, which is super fast for enterprise, is a relational database. It's called SAP HANA, part of a SAP environment, or SAP for enterprise resource planning. And that's where you have the entire database sitting within memory. But then you need to have multiple terabytes of RAM available to actually run that. But it means that you end up with a very fast database and application set. With this, in memory, we have the key values so that we can search just if we're searching based upon the first name, which I've set up my table as, then we're just searching through that rather than all the data. And we have support for peaks to come through millions of requests per second. And the platform itself horizontally scales. So the more data that we have within the system from one of these managed cloud NoSQL systems, the more partitions we have within there and the more throughput that we have for our application. All right, so this is what it looks like under the hood. So we've got a key value or partition key that is what we basically sort the database on. We can also have sort columns. So we can have something that's common to everything. So this is like an index in a relational database if anyone's worked heavily with databases. So we can create our own separate indexes that are in conjunction with the primary key as well. Right. And then we can add as many attributes as we want. Right. This can be 2, this can be 5, this can be 100, this can be 1,000. Right. So if you think again back to Instagram, if we look up a user ID, we might want to be able to see each and every one of their posts and have a link to it. So within the way that we would structure that within a NoSQL database is we would have the username and then we would just have a link to every single one of their posts that they'd made, which for me is like, 30 or something like that of my dog. But for some people, it might be 1,000 or something like that. So we can scale that out horizontally as much as we need, but it means when we look up an individual user to look at the posts that they have on Instagram, we can really rapidly find the user, but really rapidly as well see all of their post list. We don't need to wait for it to load them separately or go find or drag back the post information that goes way back in time or anything like that. It's really responsive to how we access these things. And it's this sort of technology that supports that. So as a use case, again, excuse me, this is what it might look like for a game implementation. So our players hit the game servers that give all the game access, but in the back end, the game servers pull information from a leaderboard. Right? So where we've got all the information about the users, what they've done over time. And in this case, it's reasonably set, but we could have additional information in there as well associated with any of these wins. So for example, if the Starship X game had information for the particular level that you'd won that on, or the level of difficulty that you'd had it on, you could have that associated with it as well. Another use case is a shopping cart. So we've got a web store and we want to have a whole heap of information around what users are accessing, and we want to basically fill up their shopping basket. So an individual customer access that they've had to Amazon.com or the Woolworths online website or something like that. We might have the primary key for our NoSQL database being the order number that's been created for their information. The secondary key might then be, the sort key might be the user ID that has come through on. And then we have a column for each and every one of the objects that's in their shopping cart. So again, if you're shopping at Amazon, it might be just one book. If you're shopping at Woolworths, it might be a full 2 weeks COVID shop or something like that. You've got 200 items sitting in your shopping cart, right? And we can stretch out those columns and pass that information when we've completed the order through to the order processing system. All right, so just to go back to what we're looking at, you can see here I've got my table up and running. I can go through and see that I've got the information in here of the table, and we can see the table items. So there's nothing in there at the moment, and we can create an item. So first name, we can say, Tim will add a new attribute called a string. I score, and we'll create the item. So we can see now that we've got myself in there. I can add someone else. So I can say, we'll add Jack. He's got a high score, and we can also set a new item in there at the same time.
You are far too kind, Tim. Thank you. I really appreciate these compliments.
No worries. So you can see now that we've got our primary key or a key value that's based upon name. We've got a common column that's shared between the two of us, but we can add any number of additional columns that have more information in there based upon how we access the application. Okay, so that brings us to the end of today's class. Now, it looks like we've got a bunch of questions that are ready and waiting, Jack.
That we do. I think perhaps we should go from the top and work our way down.
Yep.
Purely because I can't think of a more creative or efficient way to do it.
Sounds good. All right, so starting with David. Regarding smart city technologies, smart home and smart building solutions and services, we are providing SaaS solutions and also providing hardware, gateway, and AI hub. What's the most important part of this type of cloud-based business we need to consider? Thanks. And it's difficult to say what the most important part to consider is. I would say that the security of the environment, especially if you've got multi-tenancy for your application, would probably be the most important, because that is your largest risk profile, both from the perspective of if information gets leaked, especially if there's personal information or something like that in there, it's disastrous for your business, but also it can cause other problems for you. So I would make sure that the security, especially for a multi-tenant environment, the security stance for your application, I would put extra time into in the initial planning phases, if possible, to make sure that's up to speed. But and then take it from there. So what we would term as a DevSecOps approach. So making sure that security is part of every component of the design and implementation planning.
Thanks, Tim. And I once again have forgotten to mention this verbally, but we are no longer taking any further questions. Any more questions that are not already in the Q&A section can be directed to the forums at learn.itmasters.edu.au. Thank you.
Okay, and from Matthew, what obligations fall on the customer organisation in regards to the shared responsibility model? All right, so the shared responsibility model basically maps out what the cloud service provider is responsible for. So for managed services, they're responsible for patching things like RDS, of making sure if you've selected it, that the backups are available. and that the physical security of the site, etc., remain intact. The customer is responsible for everything that isn't that, right? So the selection of user IDs that have access to a system, how you deal with external security and other planning systems. So it's important to mainly understand what it is that the cloud service providers will be responsible for, and to what degree as well, because we talk about service level agreements, but many of the ways that technology is implemented by cloud service providers is as service level objectives. It's what they aim for and what they plan for to provide to you. It might be possible to get some service credit backs or something like that, but it's not exactly the same as a service level agreement where you're guaranteed to have that level of performance or capability or uptime. From Izara, would increasing the speed of access compromise security access protocols in any way? So not necessarily. So speed of access can mean that especially if it's a public service, if you're allowing very fast access to clients, it means that there might be a factor where someone can come in on a distributed denial of service attack much easier because there's more throughput or capability to flood your system. But if you've got a good security stance, then those controls should be in place no matter what speed you have coming through. From Tanan, could you please explain a bit more about SAND technology, Sandbox, and its relation to the cloud environment? So I think this is talking about the Australian company that is developing the Sandbox, a metaverse type platform off the back of Roblox. If in the chat, you can just say whether that's correct, Tanan. I'll just wait for a response to come back there and come back to that one. The question from Lewis, any issues moving a Windows app on with AD authentication on-premise to the cloud? So no, you can have Active Directory running in the cloud, and you can have managed Active Directory running in the cloud environments as well. So generally speaking, what a lot of companies do is they integrate their Active Directory infrastructure into their cloud environments, and it means that they have central management of all of that, and also integration with the identity and access management across the board as well. So yeah, so there's no problem with doing that. If you choose to, you can also run an Active Directory controller sort of natively in the cloud as a virtual machine if you want to avoid any dealings with Active Directory schema or any other problems you might foresee with migrating Active Directory to the cloud. Or you can just have your applications connect over your network connection back into the data center for Active Directory information, which isn't ideal, but is quite possible. All right, so just getting back to Tanan's question. So Sandbox is off the back of an Australian company, and they're deploying a new Roblox type game that has a shared metaverse. So Activision, Atari, and that sort of thing are buying space in there. And there's ties with that to NFT and being able to utilize gaming objects as NFT tokens between the games. So not exactly a cloud piece, but certainly an interesting technology piece. And Sand is essentially the cryptocurrency, which is part of that, which is also an interesting model, because you're paid basically interest for staking your cryptocurrency to provide liquidity to the crypto market. But that's beyond the scope of this, I think. All right, so from Lewis, any issues with SQL database Windows authentication on the cloud? So that's same as question before. So multiple ways that we can deal with Windows authentication for cloud environments. Where wouldn't the DB types be used? So this is from Leo. So this is one of the things we covered before. It's horses for courses. So we've got very specific needs based upon our business requirements. We can use a NoSQL database for a whole bunch of things. Like we can have an order-based system that's built off a NoSQL database, like I was talking about, with customer numbers and customer information, but it may not be the best solution for that because it doesn't lend itself to some of the business requirements that we have around making sure that the data adheres to certain requirements and that our transactions are what we termed before as ACID, right? Making sure that that we have only one transaction go through, that we don't have that we know whenever we request anything from the database that it's giving the correct answer back. Right? So we want to make sure that whenever we're choosing a database, it's the best option for the application that we've got at hand. Question from TN. Schema changes for a relational database. Does this have to do to be done while the system is online or offline? So this really depends upon the application itself. So the database itself can be, so you'd need to take the database offline generally to do a schema change, but you don't need to take the whole database server offline. So this is stretching my mind back from doing SQL administration a long time ago. But yeah, so I think you need to take the database offline. Someone might be able to confirm that for me in the chat. But you don't need to take the whole database server offline. So it means your application will be down for a certain period of time so it can update the schema. Question from Anonymous. Can you share a sample of how we can classify the files and appropriate protection based upon them? Can you share a sample of how we can classify the files? All right, so I think this is going back to where we were talking about the files, the file store, etc., and looking at security around that. Classification of files is something which is always difficult. There's been lots of tools over the years for putting in place security standards across it so that you have classified or unclassified files and things like that in file stores, and that you have rights associated with that. Now, generally speaking, that's always been difficult, but it's something that's got better more recently because there's much more integration between tools like cloud-based file storage, etc., where you'll actually get prompted before you send a file or save a file as to whether it's intended for customer use or internal use or general public, etc. So the classification process is something where that capability is now more readily available than ever. Question from Chris. Is a NoSQL database like a flat file system, generally speaking? A flat file system in regards to just a bunch of things in a directory, kind of, yeah. So if you think of it as a single folder with lots and lots of files in there, you can do with the ability to rapidly find an individual file name, then yeah, kind of like that. And from PK Carlisle, if you have an unstructured database, how do you keep the customer-facing inventory up to date? So Amazon.com tells the customer an item is in stock or not, which has to be current. Do you lose the flexibility, scalability of the unstructured model? So this all comes down to what your business requirements are, what your scalability system is, etc. But for a company like Amazon, generally speaking, they would rather have the flexibility and speed of having a system which was eventually up to date rather than having something that was entirely accurate right now. Because the worst thing that happens if they're a bit out of date and someone buys the last thing before you buy it and it's not up to date when you go to make the order, it'll go to try to fill it, it'll go through to one of the back-end systems. And it's at that point they'll go, oh, we can't actually fulfill your order because the object isn't actually there. So in the back end, they might have something like a relational database for what the actual stock looks like that feeds into a NoSQL database for the front end. Because when we're actually fulfilling orders, we're dealing with a much lower number of users, right? So there might be 1,000 users concurrently that are accessing an order fulfillment system, whereas we've got 50 million users concurrently that are browsing the website to see what's available. So there you could probably do a mix. From NG, how does an unstructured database group together merge fields if they are misnamed in one input from another? So yeah, it's a problem. So if you use even a different case for the way that you save an object. So in the example that I gave before, I used high score as one of the fields that we had for the database we were using. If I did high score with capital H and capital S, that would actually create a brand new column, right? Or if the data wasn't correct. So this is where you either need to have some control around what things look like from a data perspective with the way the application works with the database, or you need to have something else that helps manage that, because you may not have the same sort of controls as you would within a relational database. And last question, would dashboard reporting, example Power BI, be easier on a relational database than a NoSQL database? Yeah, I think Power BI is generally more attuned to a relational database because you know what all of the columns are. You can create graphs and things like that much more readily because you know that all of the columns are there, all of the data's there. Now, if you actually built a NoSQL database that was closer to an ACID style of deploying an application, then sure, Power BI would probably work fine because you have an application level that makes sure that all of the columns are the same and you have the same data, and it wouldn't matter as much. But generally speaking, Power BI will be more attuned to a relational database. All right, and there we're at the end of the questions, Jack.
Fantastic work, Tim. Thanks very much. That was not only fantastically informative, but also beautifully timed. So thanks very much for that. Thank you, everybody, for coming along to this webinar tonight. Thanks for attending. You can find any more information, as always, at learn.itmasters.edu.au. That's where you'll find the forums. If you have any further questions, any discussion points that you'd like to bring up with the other participants, generally, you know, most things about it, feel free to also get in touch with IT Masters regarding questions of eligibility for study or for recognition of prior learning via our website or my email, which is posted in the chat as well. Thanks very much, everybody, essentially. Thanks, Kit and Hannah, for your extremely helpful work, keeping everything running smoothly. And we'll see you all next week.
Thanks, everyone.